Hello. When we talk to companies about why they use DevOps and cloud for deploying their applications, they usually say that it allows them faster deployment of new applications, more flexibility as the application architecture develops over time, and faster delivery of new functionality if they use agile development and automated deployment. However, when we talk to them about how they size their cloud-based applications, we're surprised to hear that they use the same approach they used when deploying on-premise. They build the application, load test it in pre-prod, and then add some headroom and provision the cloud infrastructure they need for a successful launch. The only time they review their sizing decisions is when performance is negatively impacted by workload or changes to the application, and they provide additional headroom. So why don't companies do the measure step in the DevOps lifecycle? To do measure and plan properly, you need to capture a significant amount of information. You will need granular time series data of all the key resource metrics, including CPU, memory, disk I/O, and network I/O. This is used in the RightSizing activity. Time series data about the typical seasonal behavior of the application, hours when it's busy, hours when it's not used. Aggregated data about the types of instances being used. This can be aggregated across many applications to allow for better buying of capacity. A detailed understanding of the various buying plans which the different cloud providers use. This is ever-changing, meaning that the process needs to know the latest options available for right buying. Performance requirements of the application. If it is cheaper to buy capacity in different locations, and by knowing the performance required of each element of the application, best buying can be applied to the purchasing plan. With this broad range and large amount of data, it's not surprising that many companies do not try to manage their cloud cost, or if they do, use a very simplistic approach. To do this for a significant organization and cloud estate requires good data capture and a tool designed for the purpose. After the measure stage, it's necessary to plan for the next cycle of the DevOps loop. This planning requires looking at the historical data to identify wasted headroom in memory, CPU, disk, and network performance. It also requires understanding where performance is being restricted and extra capacity is needed. This should be modeled to understand the likely performance increase and the extra cost incurred. For example, a database may have a bottleneck in an application, and the database virtual machine is maxing out its CPU at peak workloads. It is possible to model the increase in cores or choosing faster clock speeds in the next release of the application. It's also possible to see the seasonal behavior of the application and to set policies to shut down unused instances when they're not needed and won't be needed until the next working day comes around. Finally, the cost optimization of the required estate can be looked at to decide on the best buying plan for your workload. This will include the expensive but flexible on-demand, the cheaper but always paid for reserved instance, and even the new savings plan available from AWS, which lets you blend these demands. And so we have it. The RightSize, RightBuy, and Optimise process is a critical phase in the DevOps lifecycle, which most companies don't do because it's not possible without data capture and the right tool. Following this process will keep your cloud bill at an optimal minimum, never impacting the performance of the application, but not wasting money either. For many companies in these tough economic times, the need to save money is greater than ever. Reducing headcount is not something many companies want to do, but saving on external spend is possible now. Let's have a look at right-sizing in a bit more detail. If we are moving an application which is currently running in our data center, we're able to capture all the information we need before we want to move it to the cloud. This screenshot shows our data center in Malaga, which runs the ITRS Capacity Planner tool. The blue areas are underutilized and the orange areas are more utilized. Capacity Planner shows the recommendations to improve the use of our servers in the data center. In reality, given the servers are paid for, most companies won't change out the unused capacity, but would rather grow into the demand as it increases. However, if the application is to be moved to the cloud, it makes no sense to buy the wasted capacity in the cloud, as it's easy to resize when we need it. So the tool shows the cost of moving like for like, in case we want to know the baseline, but it also shows the cost of moving the application right-sized for the cloud. In our case, this would save 28% on the one-year plan. Most cloud cost optimization tools work at the total cloud spend level, They only optimize the entire cloud estate, and for some larger companies and their applications teams, this is too broad an undertaking to take on. ITRS Capacity Planner works at the single instance level, so you can model and optimize each application separately if needed. In this example, MemoMax is an application which is memory hungry and needs fast disk. So when we are planning the migration of this application, we're able to tell the cloud provisioning team that we want memory optimized instances, which give us a burstable or dynamic memory, and solid state disks or SSD for the fastest possible disk access. These constraints are taken into the model, are costed, and are provided to the DevOps team for provisioning when the application is moved to the cloud. In this example, a client has bought an Oracle Linux 4.5 server, but when we analysed the usage of CPU and memory, we found a better instance which matched their statistical profiling of the demand. The next stage is RightBuying. Once we know what instances we need to run the application, we look at how long and where they run. In this example, much of the estate is left running all the time, with the parts of the estate being blue, meaning underutilized or idle, but not halted. Indeed, for much of the time, and many of the instances could be shut down as there was no workload. Running instances when there is no workload going to happen is one of the biggest causes of wastage in cloud spend. This screenshot shows the same estate with our RightBuying and policy management in place. The black areas is where instances have been automatically shut down and then spun back up when needed. For ITRS, this activity alone reduced our AWS bill by 75%. We reduced the bill by 3/4. The cloud providers are continually updating their billing engines, and earlier this year, AWS introduced a new purchasing plan called Savings Plan. This allows you to prepay for some capacity in advance at a much cheaper rate than their on-demand capacity. However, you need to find the optimal point for prepaying versus flexibility based on what your actual application or estate needs. This can only be done by analysing your estate's behaviour over time, seen at the bottom of the slide, and working out the sweet spot. Finally, you may want to model some future scenarios. This may be increases online activity, changes to the application architecture, or migration to another cloud provider before you make the change. Capacity Planner allows you to model these scenarios in the tool and tells you what the performance and cost implications are before you make the changes. This is the plan stage of DevOps, which few companies are doing today. I hope you found this useful and helpful. If you want to know more about ITRS Capacity Planner and our cloud cost optimization ability, get in touch. Thank you.